Engineering mechanics is a broad term relating to the effects of force and motion which govern how things behave when they experience load. We're going to combine math and physics with an emphasis on direct application. So I want you to think engineering application meets problem solving. It's not theoretical anymore. We're going to take all those math and physics things and stick them in real-world situations. And we can do that. We can model complicated behavior using some basic fundamental equations. And our goal is to make a safe, stable design that performs the task that's asked of it. Maybe we want something to weigh less. Maybe we want to generate more torque or be more reliable. And in the case of structures, maybe we want to span a farther distance, but be lightweight at the same time. So our challenges are great, but the three classes that come together will give you the knowledge to approach these problems. So there's three classes: statics, dynamics, and strength of materials. Statics is definitely one of students' most favorite classes because you feel like you're an engineer for the first time. You're going to study things that are primarily at rest. And what we say is that the forces are balanced. Something pushing one way is exactly balanced by a push or pull going the other way. A twist one way is exactly balanced by a twist going the other way. And we call that equilibrium. And if you're in equilibrium, if the system is in equilibrium, it's not accelerating. And that's a fancy way of saying it's not speeding up or slowing down. Okay, so that's statics. In dynamics, we say the forces aren't balanced anymore. The thing can speed up or slow down. It is going to experience acceleration or deceleration. So the best analogy for that is to think about hitting the gas pedal in your car. You're going to speed up. You got more force going one way than going the other way. And maybe this is drag and friction, but you're overcoming that. And you're not just balancing it, you're overcoming it so that you actually speed up. And then you hit the brake pedal and you start to slow down. Why do you slow down? You got more force going one way than the other way. So when the forces are not balanced, or it could be twist and rotation, but when they're not balanced, then you have acceleration or deceleration, and that's dynamics. Okay, so you have statics and dynamics over here. One thing speeds up and slows down, the other doesn't. And then we're going to combine those into the third course. The third course is strength of materials. And in the first two courses, we said that, hey, maybe everything we're talking about is rigid because we don't want to deal with material properties just yet. We're still learning the push and pull part of it and the motion and all that. Well, in strength of materials, we say, hey, how does the material react? How does the material affect all these things that we've been talking about? Because keep in mind, things bend and flex in the presence of these forces and torques. So how is the body affected? And how do material properties affect all this motion and things that we've been talking about? Things can twist and bend. We say this table, for example, it's a maple, hard table. Some things aren't hard like this table. Some things are soft and flexible. So how does that play into all the motion and physics and engineering application that we just talked about in the other two applications, or the other two courses? How's that going to play out when we care about material properties? And it's interesting. I mean, why do we kind of really like this wood for structural applications, but maybe don't want to use it in the aerospace industry? And what makes plastic composites so interesting? So that's the material aspect of it, and that's going to come in strength of materials. So the great part about these three courses, they represent kind of like the pillars, the foundation, if you will, for your engineering applications. You will have the knowledge to approach typical problems encountered in almost every engineering application. It might be material science, civil engineering, mechanical engineering, biomedical, architectural, aerospace, you name it, these three classes are part of it. In fact, when I worked in industry, we wouldn't hire an intern unless these three courses were under your belt. They represent everything else that we are going to build upon. And so it's a great set of classes in this microcred. I hope you enjoy it.